All right, bottom half page 2 all the way to page 3, which should end up day 1. And here we go. We're going to identify a function's domain. Domain is the x value. Range, that's the y value. All right. And the end behavior, and that's what's happening on the ends of the graph. All right. Domain of f, the set of, that is also called the inputs values, which is x. Range of s, set of output values, which are y. So you input your x into an equation, and out comes a y. All right. So we're going to state the domain. I'm going to come over here and sew domain right here. All right. And we're going to do them all as what? Inequalities. So I'm going to write NEQ. We're going to do it in set notation and interval notation. So inequality here, it looks like the domain of this right here is all real numbers. So I'm going to say, I'm going to do it like this. I'm going to say negative infinity is less than x, which is less than infinity. Looks like my range, right? So my domain for that, my set notation is going to be the same thing, which is this little bracket with x bar, and we're saying negative infinity, which is less than x, which is less than positive infinity. And in interval notation, can't touch infinity, so parenthesis, negative infinity, comma, infinity, and there it is. Range. So range is going to be pretty much the same thing here, right? As an inequality set and interval. Look, range is my y values, and this goes up and down forever, right? It goes down forever, up forever, just like it goes left forever and up and right forever. So inequality negative infinity is now less than y, which is less than infinity. Set notation, but now we're talking about y, so we say y bar, right? Negative infinity less than y, which is less than infinity. And interval notation, same thing. Can't touch negative infinity. Goes all the way up, so it can't touch infinity. Alright, so now we're talking about the end behavior. Okay, the end behavior describes what happens to the output values. That's f of x is output as the x values, as the input values either increase without bound, approach positive infinity, or decrease without bound, approaching negative infinity. Alright, so we're going to write that. We're going to say as x increases without bound, we're going to say approaches infinity. See that? Approaches positive infinity, comma, we see f of x, so I'm going to say, I could say y, but we'll say f of x approaches, and let's see what happens. It looks like as x approaches infinity, y goes up, so y approaches infinity. And there it is. So let's do decreases, and we're going to say as x goes towards negative infinity, comma, my output y or f of x also goes towards negative infinity. That's just saying, hey, as we go left, the graph goes down. There it is. Let's do a couple more. That's page 2. We're going to get all page 3. Won't be too bad. So here we go. So domain and range. So I'm going to do domain and range. Let's just do domain first. So I'm going to hit domain. So this looks like my graph always goes left and right. So I'm going to say for inequality, I'll just write in. We got set notation, so we'll do set notation next, and interval notation. I'll say I period, N period, interval notation. Alright, so as an inequality, it looks like x is greater than negative infinity and less than positive infinity because it goes left and right forever. For set notation, I'm just going to do my little x bar here and say the same thing. Alright. I should have did a better bracket there. And for interval notation, negative infinity, positive infinity. And for my range, let's do the same. All right. So we're going to say goes, well, my y only goes down to 0, but it touches 0. So I'm going to say 0 is less than or equal to y, which is less than, can't touch infinity, infinity. I could have just said y is greater than or equal to 0 and stopped there, but I wanted to hit the whole thing there. So we're going to say y bar. And let's go ahead and say that over here. We could say y is greater than or equal to 0. That implies we go up to infinity. Either way would be okay. All right, for an inequality, we touch 0, so we're going to say this. We can't touch infinity. That says I go down to 0 and up to infinity. Always the smallest to the largest. All right. Now we're going to do end behaviors. End behaviors. All right. So we'll start by saying as x goes to infinity, comma, y. Well, as x goes to infinity, y goes up. Y goes to infinity. Then we'll say as x goes to negative infinity. That just means down forever, comma, y. Well, y is still going up on this side, isn't it? Y goes to infinity. Not too bad. All right. I'm going to hit a couple more. Let's do this guy right here. Okay. So I'll just write the precursors, domain. We'll do inequality. All right. We'll do set. Okay. And interval notation. So let's see. My domain is on my x's. It looks like it goes left and right forever. So there is no change between this one and this one up here. So negative infinity, less than x, less than infinity. Same thing here with x bar, negative infinity, less than x, less than infinity. Keep going, you're getting there. And negative infinity to infinity. Now my range, my y values, how far up and how far down I've gone. Well, it looks like I've only gone down to 0. And when you see this, you assume it doesn't touch. It's approaching, and it looks like it's touching, but anytime you see a line approaching, like in this case the x-axis, you assume it doesn't touch. So my inequality is 0. X is greater than that. And I'm going to write it two ways. I'll say less than infinity, right? And over here I'll do it the other way. I'm going to do x bar, or it should be y bar, isn't it? I messed up here. Let's make that a y right there. And then I'm going to say y is greater than, not equal to, we're going to assume it doesn't touch 0. And since we don't touch, we're going to use a parenthesis all the way up to infinity. Let's talk about our end behavior. We're almost there. Alright, so here we go. As x approaches infinity, let's see what y is doing. Y looks like it's going up. Y approaches infinity. Let's get the other way. As x approaches negative infinity. Well, y, it looks like it's going to what value? It's not going down to a negative infinity, right? It only drops down to about 0. Alright. Here we go. We got another one. Let's hit these guys. I'm going to hit C with you right here. And C is pretty close to what we've been doing, so shouldn't take too long. And it looks, I'm guessing I might skip one of these. I might skip E and let you do E on your own. I'm going to circle that now, but let's go through C and D together. Alright. So I'm going to write domain and write everything out. Domain, inequality. If you want to pause this and try it without me, that would be great, right? And then you can kind of just see what I've got written pretty soon. Alright. So it looks like x still goes left and right forever. It's tricky, it changed the y on us, but it still goes left and right forever. So the same thing we've been writing, right? Less than x, less than infinity. I really could say all real numbers, but I'm not going to do that right now. So we can get used to that x bar and doing everything like we've been doing it for years. You've practiced this a lot. Hopefully it's come pretty normal. Interval, negative infinity, positive infinity. Let's go ahead and do range. All right, we've got our range coming here. So range is y values. Doesn't matter how far left. How far down is 0. We touch 0. It looks like it goes up forever. Doesn't matter which side I'm going up forever. I'm still just going up forever. So I would say 0, and we touch it, so we're going to say less than or equal to y, less than infinity. And we got our y bar. Alright, we got 0, less than or equal to y, which is less than infinity. And yes, I could have just said y is greater than or equal to 0. That would imply that it goes up to infinity. We're going to use a bracket because I touch 0, and I can't touch infinity. Here we go with the end behavior. I'm just going to say EB in the interest of time. I'm going to say as x goes right. That's to infinity, right? Gets bigger, comma. Y goes up, infinity. And I'm going to say as x goes down to negative infinity. Y goes up to positive infinity. And I'm going to do one more. Leave you to yourself, and if you'll notice, page 4 starts day 2. So we're getting through the first day of notes right now, and then we'll practice tomorrow in class. Here we go. Graph is shown. So domain, let's just list them out. Inequality, IN, set, right there, and interval, interval notation. I'm going to say IN. With a capital anyway. A little bit different. Let's just get through it. Looks like x goes left and right forever. So all of these have been the same pretty much. Negative infinity, less than x, less than infinity. Set notation, same thing, except with that x bar and the set notation, kind of those little, really that is set notation. Less than x, less than infinity. Right, and then interval notation, we cannot touch either one of those infinities, so we use parentheses. Range is a little bit different. Look, this is a little tricky. It never goes below this point, which is the y value is negative 3. So negative 3, which I touch, so is y is greater than or equal to negative 3. And here's the tricky part. It looks like that might be the top of the graph, but you can assume this arrow is going to eventually go over that because the arrow goes on forever. So we're going to say it goes up to infinity. So in set notation, same thing with y bar, right? Negative 3 less than or equal to y, less than infinity. And interval notation, looks like we start at the bottom, right? We touch negative 3, so we use brackets up to infinity. And end behavior, as x goes to infinity, it's like y is also, y goes to infinity, and as x goes to negative infinity, y is going up, y goes to positive infinity. I'm going to leave E for you to do, compare tomorrow in class, and you're done. So this has been less than half an hour. It's going to make tomorrow practicing really easy, and maybe we'll get a little bit of the notes done too. I'll see you tomorrow.